screen, and I think I know how I can fix it. But for the sake of the stream, I git reset it up to where we had the last commit, and I'll work from here. So one mistake that I made was I'm converting x to a number input, but I'm not converting the up and down. Why did I rename this to up and down? Do I want to rename it? Does it matter? But anyways, I'm not converting that to numbers, and then we have a problem, because if we have string 9 is less than string 10, it's false, whereas obviously 9 is less than 10. So that's a big problem here, and I want to convert everything in this array to a number. And because I copied and pasted my code a lot, I have another instance. Oh, this is hard. I have another instance of this, and it's up here. Okay, so now that I've converted those two numbers, I think at least my input should be right. And we can start coding the waterfall. So git d1234, git commit minus a message fixed reading input. All right, so the waterfall, as I tried before, this was the print function. I want to make this recursive. What should I call it? I guess I'll call it flow. It takes the board, it takes an X and a Y. And the X is actually 500 minus the X offset, and the Y is 0 because I'm in the middle row. Oh my, this code is lots of copy and paste. Don't want to see this. I don't need this. Actually, I think I don't need Y offset. Do we need Y offset? Oh, it's used in here. Never mind. I'll just keep this for now. All right, so let flow is a function that takes the board, an X and a Y coordinate. And now it's dribbling down from the top. So if board of Y X is a dot, then board of Y X is a floating water. Okay, that's the first thing. Sorry, I need to fix my microphone. Okay, so that's the first thing. Now, if board of Y and X is hard clay, then we need to know where the hard clay is. If the board of the next row and X, if that is, and before we can work with that, I guess we have to check if Y is equal to board.length minus 1. That means we can't go further down, so we just return here. But if the dot below is, if the square below is open, then we just want to call flow of x, y plus 1, always on the same board. So this now calls everything below, and then at some point, if the thing below is equal to a dot, no, not a dot, if we hit a wall, or if we hit standing water. So we hit standing water, so now we want to go left and right until we're at the end of it. So let left is equal to flow of xy on the board, and we want to go x. If we're going left, then we're subtracting 1 here. And this is always on the next row. And on the lower row, we're going to the right. And we're doing this, if they're not that, again, we need to know where this ends. So if board of y comma left is equal, if we hit walls on both sides, now I need to fill up the board. And right, then for let I is equal to left. We don't want to overwrite the board. I is less than right. What is this complaining about? That one. Then we want to set the board of yi is equal to fill it up. All right. So if we have a dot, we set it to a line. And if we hit because we're either flowing from the top or we're floating from the side. If we have a wall, we need to return the position of the wall. Okay, if we're at the end of the board, then we are done. Whereas if we are not at the end of the board, we will go 1 line down, and if it's a dot, then we're just flowing there, but 1 lower. If the board of yx, xy looks good, if the board 1 below is a wall or standing water, then we do left and right is what we call floor right. Oh, and we might be doing this forever, so I want to indicate that we already did this and we're only going left, and here we're only going right. So we need a direction. If direction is equal to left, and we want to return flow board x minus 1 y going left. And if the direction is right, then we're going right. Right, and then left is the flow, left and right, but I want to say at the same height because we need to add these lines in. And if we have a left and a right wall, then we're filling it with standing water. Okay, and then we are printing this. So Node.js 17. Yep, that looks good. So now instead of printing, or maybe in addition to printing, instead of printing for let j equals 0, j is less than the width, j plus plus, let water is equal to 0, and if board of ij is equal to standing water, or if board ij is equal to floating water, then we want to water increase, and then console.log water 57. That looks right. Now let's go to the real input and see if that actually works. Okay, submit. Yes, okay, continue to part 2. Okay, in a sample after a very long time, the water spring will dry run. How much water will be retained? Wait, the spring will dry run. How much water will be retained? An example above water that won't eventually drain out is shown as, oh, as tilde 29. Okay, that should be easy. All right, let's see. On the test input first, we want only the water that's fixed. Nope, that didn't work. 29 sounds good. Okay, let's see with this number. All right, okay, yes, let's share this on Twitter. I just completed day 17 of Advent of Code. Remember, yeah, I want to add in that screenshot. Remember, though 9 is less than 10, 9 less than 10 is false in JavaScript. Do we need a link to anything? Nah, I don't think so. I do need a smiley though. Okay. Cool. This is incognito. Okay, I'll post it from regular Twitter. Sorry about that. Okay. Cool. Should we go ahead and try the next one? I guess so. I'm a few days behind by now. But also it's pretty late and maybe I should go to bed instead. I think I'm going to start the next one and then think about it while I sleep and then finish it tomorrow, hopefully. All right. Okay. Settlers of the North Pole. On the outskirts of the North Pole-based construction projects, many elves are collecting lumber. The lumber collection area, oh, so now they're not dehydrated, so that's good. The lumber collection area is 50 by 50. Each one can be open, trees, or lumberyard. Oh, this sounds like the water floating in clay. Take a scan of the area. So we have a 50 by 50. Strange magic is at work here. Each minute the landscape looks entirely different. In exactly 1 minute an open acre can fill with trees. Oh, I need to write this down. So I have open is a dot, tree is a pipe, and what does lumberyard even mean? Lumberyard is a lumberyard, lumberyard. Yeah, I did mean lumberyard. No, I don't want Amazon lumberyard. Google, you're letting me down. Dictionary. Oh, a place where wooden boards are kept for sale. All right, so, all right, and here at each minute, it open can fill with trees. A wooded acre can be converted to a lumberyard. Okay, and a lumberyard can be cleared to open ground. Okay. The change to each acre is based entirely on the contents of that acre, as well as the number of open, wooded, or lumberyard acres adjacent to it. Oh, so this is another Conway's Game of Life state machine. Okay, here JSON means any of the 8 acres surrounding that acre. Okay, the missing ones aren't counted. All right, an open acre will become filled with trees if 3 or more adjacent acres contain trees, otherwise nothing happens. All right, so these are the rules. The changes happen across all acres simultaneously, so we're just going to keep 2 maps to compute them. Okay. Well, there's some test input. After 10 minutes, there are 37 wooded acres, 31 lumberyards. Multiplying the numbers of wooden acres by the number of lumberyards gives the total of this. All right, what will be after 10 minutes? Yep, I think I can do this before it's too late, but I might be a little bit too optimistic. Get your puzzle input. Okay, get the puzzle input. I guess I have to look at these rules more carefully. Okay, so the open one will become filled with trees if 3 or more. Oh, that's an easy rule. Greater or equal, so trees greater or equal 3. The tree one will become lumberyard if there are 3 or more adjacent acres were lumberyards. Oh, so lumberyards greater or equal 3. An acre containing a lumberyard will remain a lumberyard if it was adjacent. I need to negate this sentence. So lumberyard will stay lumberyard if we have 1 lumberyard and 1 tree, and it will become open if we have at least 1 lumberyard and at least 1 acre, then it will stay. So if we have 0 lumberyards or 0 trees, so if there isn't any lumberyard, we don't have at least 1. And if there isn't any tree, we don't have at least 1 either. All right. Oops. Well, let's get coding. So let me take you with me to the coding screen. And do I actually fit the whole screen on the window now? I feel like I changed the layout accidentally. Oh yeah, there's a little bit on top here. Let's see. How does this look? New file. Let's save this as day 18. And I think, no, I don't want to copy everything. I'm just going to copy this. And then the rest here, main. I can just let main is a async function that does let inputs equals await read input. And then we're calling main. Okay, that's 18. And then we need this one here as input 18. Nope, wrong copy and paste. Just heading over to copy and paste the input again. Here's the test input. Need to copy that as well. This is the initial state. Yes, all right, so we don't need 17 anymore. We do need to commit this to Git. Okay. Day 17, part 1 and 2. And now here for day 18, git add day 18 and input. Initial import day 18. All right, how does the screen look now? We're starting at row 4, so they're still a little bit cut off, I guess. The last one looks good, so let me make this smaller and just double check here. I guess I can make it bigger. Because it looks okay in the OBS preview. Does it look okay here? Maybe. Why is the top not in it? Oh, because I'm not scrolling to the top. Bummer. All right. So we have all the inputs. Now let's get to coding. So the inputs that we're reading are the map. And we know we have a 5550 board. So let's just keep calling it board is an array of 50 that fill, and then we are mapping everything to an empty array. And now we want to say for let line of inputs, so for every line, which will look something like this, line that split. So now we have an array, and for let character of line that split. No, this is not going to work. I need the, oh no, this is, I don't need to copy them over. I'm just splitting them into an array, and then I say board of I is equal to line that split, and I need my I, let I equal 0, I plus plus. So now we have a board where the first entry is a row. If the entry is a row, that means we have y, x coordinates, okay? Now we need, for every one of the things on the board, we need the adjacent fields. So we want a function let adjacent be a function that takes an x and a y coordinate. And I wanted to return an array that has the number of open ones, the number of trees, and the number of lumberyards in it. So we want the open spaces, the trees, and the lumberyards. How do we get the adjacent ones? We're doing the top, the middle, and the bottom. So if x is bigger than, if y is bigger than 0, that means we can take the top row, let fields equal an empty array. We take the top row. If x is bigger than 0, then we can take the left one, and we want to fields that push, and we are pushing y minus 1, comma x minus 1. And if x is less than 50 minus 1, then we're pushing the one on the right. And we're always pushing the one in the middle because we know that that exists. If y is bigger than 0, now we do the two middle ones. So basically these two. and we're pushing left and right x. And now we're pushing the bottom row. If y is less than 50 minus 1, then we want to push y plus plus plus. All right, so this is what we have in fields for let field of fields do something. So let result equal an empty array that has 0, 0, 0 in it. Okay. If let these are y and x. We already have y and x, so let's call them j and I of fields. If the board, adjacent of course needs a board. So if the board of ji is equal to an open field, then we want to set result of 0 is what we had before, plus 1. Else if it is a tree, then we set the second field a little bit bigger. And then the last one, we already know that, but we're checking anyways. If it's equal to a lumberyard, then we set the third one bigger. And then we'll return the result. So this is how we get the adjacent ones. Now we want another function. Let new field is a function. It needs the board. Oh, and it will return a new field, I guess. No, it just takes the, what does it take? It takes the board, it takes an x, it takes a y value. What did adjacent take? X, y. Yep. An x, y value. And it says let adjacents equal adjacent of board x and y. Okay, if board of yx why can I not call it adjacents? Let neighbors, oh, this is missing. So board of xy, if that is equal to an open field, if adjacent, if we have more than 3 trees, then it is changing to a tree. So if adjacent of the trees of the second entry is greater or equal 3, then return it's turning into a tree, else it does not change at all. Okay. If the board is equal to a tree, and if we have more than 3 lumberyards, then it is turning into a lumberyard, otherwise it is remaining a tree. And the last one, if the board is equal to a lumberyard, and if we don't have a lumberyard, if lumberyard of, if the lumberyards, if that is equal to 0, or if adjacents of, we have no lumberyard or no tree is equal to 0, then it is turning into an open space, and otherwise it is staying a lumberyard. All right, let's see here. This is silly. Let open tree lumberyard. So if we have tree bigger than 3, if we have lumberyard bigger than 3, or if we have lumberyard or tree equal to 0, then it returns to open. All right, so this is what's happening on a field. And why I'm not counting the open ones? Because nothing is depending on whether something was open. All right, so let's not count those. Okay, so we filled up the board, and now we need a new board. And for let I is equal to 0, I is less than 10, I is increasing. Oops, need my headphone. Otherwise the microphone's gone. Okay, so I is increasing, and I want, for every element on the board, I'm applying that and I'm adding it into the new board or next board. So for time, let I is 0, I is less than boarded length, I plus plus. For let j is 0, j is less than board 0 dot length, j gets bigger. And now we want what does this new field takes board x and y, new field takes a board and x and a y value, and we're assigning new board of x, y equal to the new field. Now what will we ask? So now we have this new field. Once we're done with this, we're saying board is equal to the new board. Oh, new field is the function. Yeah. Okay, so then we're resetting this. This was initialized. We take the old board and we reset this. And then at the end, what was the question asking for? Oh, I should probably print those. Okay, after 10 minutes, there's 37 and 30. So we want wood and lumberyard. The total resource value is those two multiplied. So number times, what is the total resource value of the lumber collection area after 10 minutes? Wood and acres, multiplying those two numbers. All right, let's try this. For I, for j, let wood, let lumberyard, and if the board of ij is equal to wood, then wood goes up. Otherwise, if it's equal to Lumberyard, then Lumberyard goes up, and then console.log board multiplied by Lumberyard. Node day 18. Well, that worked really nice in line 92. Cannot set property 0 of undefined. Cannot set property 0 of j, because the i's are the, what am I doing here? I, j, if board of ij. And this is in line 92 still. Cannot set property 0 of undefined in 92. New board of ij. Time goes up. The new board is an array of size 50. What's wrong with my j? ij. It's the board length, and that's the, so that's the height, and that's the width. And the input that we're reading, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's only 10 by 10. Of course, I hard coded this. So let board at size equal to 10. We want to replace all 50s with size. It's an area of size. If it is size -1, size -1, size -1, size -1. Okay, and now it's 10. Size is not defined because I'm defining it inside this function. So let's make this global. Okay, and we still cannot set property 0 of undefined in line 96. Size is 10, 96, board of ij. Why not? If type of board of I is equal to undefined, console.log I. Why does this not work? If it equals undefined log I. 99. Cannot set property 0 of undefined. Well, let's just hard code it. Cannot set property 0 of 10. Why would the board length be 1 too big? Why is I equal to 10? So we have an array of 10 that we're filling with empty ones. And now for every line, board of 0 is an array. I is board that length, and y is board that length 11. Console.log board that length. Oh, because I'm reading the completely different input. That was hard. All right. 10 and 0. Where am I pushing the 10? I'm printing the 10 somewhere. Yeah, I don't need to print the board length. All right. But I do need to print the old board. So once I have, no, that was silly. So once I have this for let I is equal 0, I is less than board dot length I plus plus console.log board.join and console.log. And actually I want to print the initial board as well. Okay, and the board is wrong. It needs to be off that one line. All right, let's compare those. Oh, yeah, I need to print the first one correctly to board of I. All right. So we're starting out. Oh, that seems to look wrong. Let's have a look at this other input. Okay, we're starting out like this. And the first ones, I'm just comparing those. I can't show those because I only have one screen. And then I'm doing the second one that also looks good. And then after 3 minutes, looks good. After 4 minutes, there's more of them. After 4 minutes. Oh, I have a mistake going from 3 to 4 minutes because for some reason I have an extra tree here. Here, 1, 2, 3, 4. I should print out my eyes with this as well. So when I'm printing these, this one here is console log 0, whereas here I want to say console log plus I plus 1. All right, and so somehow one that is open does not get converted to a tree. So what did I do wrong? I have an open one and I have 3 trees below it, but somehow it doesn't get converted. So the new field one, if it is open, if the number of trees is greater or 0 than 3, then I'm returning a tree. Okay, that rule is correct. Y-X, board XY, and now if I'm looking at adjacent of board XY, so this is one in the top row. So Y is greater than 0, that is true. So we are pushing in y minus 1, x minus 1, y minus 1, x, and y minus 1, x plus 1. So we push in y comma x. And then we take out y comma x. Yeah, that looks okay. And then x is greater than 0. Oh, of course, I'm missing. No, this is the next row. X is greater than 0, so we take the left one and we push the right one. And if y is less than size minus 1, if y is less than the size minus 1, wait, if y is greater than 0, which it is not, so we're not doing this first row, but we're doing this, and then if y is less than this, we're pushing y plus 1 and x to the left, and then here we're pushing y plus 1 and x to the right. That looks all correct to me. Does anybody see a typo here? So let's debug this. Let me figure out which one was the broken one. So the broken one was in y equals 0, 0, 1, 2, 3, 4, 5, 6. 0 and x equals 6. Let's put some debug info in here. If y is equal to 0 and then x is equal to 6, console.log debug e.06, and it has res. All right, so, oh gee, why am I doing this so many times? Didn't I print I? Oh, I need to print time, sorry. Console log, where's my print loop? Console log time plus 1. That seems to make more sense. Yep. After 10 rows. So from 3 to 4. Wait, this time it went okay. Okay, I need to see these next to each other. So after 4 iterations, oh, now it's all right. What did I change? Weird. After 5 iterations, oh, that's where it starts breaking down. I'm getting all these holes in there. Okay, I need to compare those from the beginning. So the initial one, yep, looks right. So after 1 minute, still looking right. After 2 minutes, no, after 2 minutes there's something wrong. This one here should be a dot. For some reason it's not. The one above, everything still looks good. But this one should be a dot because we're moving from tree and we don't have 3 lumberjacks around it. That's so weird why they would differ though. This is all okay. And if I look up here, I have a dot and I only have 1, 2, 3. This one's correct, but then this dot only has 1 tree around and for some reason is turning into a tree. Oh, and which position is this? It's where x is equal to 9 and y is 9, 8, 7, 6. So y is equal to 6, x is equal to 9. Why is that not correct? And that's the case where y is equal to size minus 1. So y is not less than size minus 1. No, x. X is equal to size minus 1. So let's debug this. If y is equal to 6 and x is equal to 9, and we really just need 3 iterations, I guess. One, two. So 0, 6 claims we have 2 woods and 3 other ones. It doesn't even have that many neighbors. All right. Console.log the fields. So when we're going from 2 to, no, we want to go from, how is this one turning into wood? Because here we have 1, 2, 3, 4, 5 in here. And they're all, this is a 1D array. This is, isn't that wrong? Oh no, these are the adjacent ones, right? So if we're debugging not 0, 6, but 6, 9, if we have 6, 9 here, then we have 5, 8, 5, 9, 6, 8, 7, 8, 7, 9. So the adjacent ones look good. The adjacent ones look good. But these are IJs. No, they're JIs. They're like Y axis. If the board is equal to a dot, then we increase res 1. If the board is equal to a bar, then we should be seeing, so we're debugging Y. Y is 9, 8, 7, 6. Nine, 8, 7, 6, and we should be seeing I need to look at my output again. So 0, and then after 1, this one is open, but after 2 minutes, for some reason, it closed. So here we should be seeing 1, 2, 3, 4 dots and only 1 Y. So Y was 6. Yeah, here, 6, 9. These are our fields. And for let y comma x equals of fields console.log, this is tedious, x comma y has value board of yx. Reference j is not defined because I want a y here. All right, why is this dot changing the wrong way? Because 9, 5 supposedly is a bar. This is not a bar. Am I using the new board already? What is this reading? So 8, 5 is 1 over and then 5, 0, 1, 2, 3, 4, 5. This is never ever a bar. Where am I pushing those? I'm not pushing those. I have a board. All right, I take a new board. I know what I did. I'm assigning one board to another, so I'm really working on the same one. So they got all tangled up. So I really don't need this whole debugging thing. All right, where am I copying over the boards? Board is equal to new board, so let's take this fun line again. For every board, we want to say new board of I is board of I that splice, removes element from an array, and if necessary, inserts new elements. Okay, slice returns a section of an array. Yep, I want the whole one. 488, and 488 was not the right number. So let's keep checking what's wrong here. Oh, I know, I broke too early. No, I set the length somewhere to 3 instead of 10. 435 is still not the right number, and also it's not quite the right picture. So let's see when these pictures diverge. After 2 minutes. Oh, great. They diverge after like 1 or 2 minutes. So yeah, after 1 minute, it's already off. Oh, gee. What happened this time? So after 1 minute, nothing changed at all. And then after 2 minutes, after 2 minutes, I have the correct picture. Why am I printing the initial state twice? Let's fix that. New board is board.slice. Oh, and then I'm overwriting it again. Wait. Okay, so the first iteration, nothing happens, nothing ever happens. All right. New board of I is board I that slice. That, of course, is wrong. I want to say the old board is now the new board. I think it's really too late for this. And I have to write number. So, ready, size is 50. Okay, let's see if that worked. Here's the window. All right, that's the right answer. Continue to part 2. This important natural resource will need to last for at least thousands of years if the Earth's collecting this lumber sustainably. What will the total resource value of the lumber collection area be after this many minutes? All right. So I don't think I can collect it this many times. Maybe I can. I mean, might be. Let's just see what happens. So we want to set this wherever time was this many times. And then, ooh, that looks really cool though. Whoa, that looks really cool. Got the feeling though that might be a little bit too slow. What if we're not printing everything? but I don't think that's gonna fix it. So this is where we're copying, and we keep printing time plus 1. So what will it be after 10,000 ones? Oh yeah, we just need the number of resources. It wasn't 10,000 though, it was like, okay, that number is too huge, I think. Maybe I can talk it through. So while this is running, what could we be doing? If we have a resource number for this kind of number, it should be, this is making me nervous, I need to stop this. So for every board, I think we can calculate the resource number. Let get resource number is a function that's doing this. And then it returns Lumberyard multiplied by wood. And it needs a board and nothing else. So here console log get resource number of the board. This looks a little cleaner. This is printing the board every time. We don't need that. All right, so here time is 1. So we have a board. So we want, what do we want? We want a list of resource numbers. And then in there we want to see a pattern. Oh, that sounds like day 1 or something. Let resource numbers equal an empty list. So here we want to say get resource number of this new board. Let number is equal to this, and we're pushing it into resource number. Resource number that pushed this number. But we're also doing let s equal a new set. And if s that has n, then is this already a pattern? How do we find them in the right row? Let's make this a map. If f has n, then we want to see the next index. Somehow I want to find where these patterns are repeating. And I guess, how do I find a pattern in the best way? Okay, this solution is taking me so long, I probably could have just let it run for 10 million iterations. I don't know how many this is. Nah, it's 1 billion, so maybe that's too much. All right, so let's find the pattern. So we have a list of resource numbers. And we want to find that resource number. So if we have s, s dot set n, and the index is time. But really, I need to look at this example if we do this 9 or 10 times after 10 minutes. Okay. So this one is after 0 minutes. No, this should be after 1 minute because we're not, oh yeah, we should set it here for the previous board. Okay, but anyway, so after 0 minutes, after 1, yeah, time will be 9. Okay, that's fine though. No, let's do time plus 1. So after this many minutes, we have this number here. And every time we add a number, we push it in here. If we saw it before, now we need to test the queue. If we saw it before, if S that has N, how do we store a whole number? So I have a number, and now I want to check if the next one is the next candidate. Okay. Let next candidate. Yeah, I think I need to get the resource number. So we have the board. We get the resource number. This seems to be wrong. So we take the resource number, push the first one in that. I don't need to check if it's in the set. We can just set N after 0 minutes, and the next candidate would be equal. Which way do I want to do this? So what I'm trying to say is, if you found it, oh yeah, next candidate is equal to N. Okay, and so now down here, we're taking the resource number, we push it in the list. Oh, I'm too tired to think of this. Can I just do 2000 iterations? See if the sequence repeats. Take the last one, find the, yeah, I'll just do that. So let's do this 1000 times, and let's get rid of, yeah, I want to push in the first one. The resource numbers might be repeating, but maybe it just works. N is a resource number that push. Okay, so now we have 2000 resource numbers. So this is after 2000 iterations. Let last equal resource number of resource number that length -1. And now resource number that last index of, we want to find last, and we are starting here. Let repeat equal let repeat index console.log with the repeat index. All right, the repeat index is at 1000. That could be true, that the thing has length 1000. Oh no. No, how am I finding the last one? If I want to exclude the last one. Last index of returns the index of the last occurrence. The search, if omitted, it starts at the last index. So if I'm starting at the second last one, that's better. Then the repeat index is 972. So let end equal, if it is equal to 1000, then we want the end minus this. So maybe have a sequence of length 28. Let's just check that that is true. Yeah, it seems to be of length 28. And now let's just check that this really is identical. So we have a repeat index and we have a cycle length. Let cycle length is equal to this. And now for let I is equal, the repeat index starts here. I is less than the end I plus plus if, oh, I want to compare two of them. So I really need to do and minus cycle length minus cycle length, and if this is less than minus cycle length, so I'm 2 cycles away. If resource number of I not equals to resource number of I plus a cycle length, console.log no match. Let's see if that really was the cycle. Oh yeah, that really was the cycle. Okay, so we did this for end many times. So we have a cycle. So now let b is equal to that big number. I think I just want to copy and paste it so I don't have too many zeros. All right, let b is equal to this. So we have a cycle length. So you want to do b minus whatever the end was. And from that, we do this as cycle length. Let index is equal to this. Yeah, because at end we have this index, and then that should kind of work. They don't give us, okay, I probably have to think about this some more. Okay, but anyway, so we have a cycle. Does this work on the real? Oh, this is the real input. Okay, so we have a cycle. This is the index, so we should be printing console.log of index. So b is this big number, and we know at b minus the end, this is how many we have left, modulo cycle index. Oh, that could be right. Let me not print that thing all the time. Okay, we didn't get a number. Console log, what is index? Index is 8. And And oh, console log of console log. This should be resource numbers. Resource number is not a function. No, it is not indeed. It's an array. Okay, and we're claiming there's this many left. That would be very easy. Yep, and that did not quite work. All right, so let's think about this. I ran this for and many times. And after and many times, I know that the last resource number was this one. And I mean, I guess it's easy to figure out if I have an off by one error. So I was running this 2000 times. So let's say we want b equal to 2500. And let's print that one out. So for 2500, I'm claiming that it is 26335. And now let's do the other version where we're going to 2500. There's a bit too much that I'm printing. Let's go to 2500 and console.log that last number. So this is the right number. Okay, let's add or subtract one. 19514 would be the right one to 2500. So let's go back here. Resource number of index plus 1 maybe. Nope, that's not it. Index minus 1. Nope, that's not it. All right, so maybe the cycle. No, if that's the cycle, then that's the cycle period. So we have the cycle, then this calculation here is off. So I want this for a total of 2500 iterations. We already did 2000, so there's only 500 left. And how many times does the cycle length fit in this? That doesn't really matter. What matters is how much there's left over. So you're taking the leftover ones as the cycle length. Oh, I don't want resource number of that number. I want resource number. And I really need last. No, last is the last one. Repeat index is where we started. I need repeat length minus a cycle length plus the index. And that is the right number that I was getting with the other example. So let's try this, not with 2000. Oh no, 2000 was good for the iteration, but let's try it with the 10 million. Okay, ready? Ready in the browser. That's the right answer. Awesome. Okay. Well, thanks for watching. Oh yeah, I need to post this when I'm logged in. I just completed this one. All right. All right. Cool. What do I need to do here? I need to clean this up just a little bit. Index minus p cycle length, no match, throw new error. Really can't repeat them. Format a little bit. Don't need the cycle length, don't need the last index, don't need this one. This is only if I'm printing the board, which I'm not. Oh yeah, this was some nasty debug output. Okay. Day 18, part 1 and 2. All right. Thank you. See you for part 19 a day later, I guess. Bye bye.